name is Glenn Booth, and I am the CMO for Dometis, the U.S. division. And Dometis is a developer of powerful software tools for telecom broadcasters and media carriers. Co-presenting with me today is Wes Hannemeyer from Hibernia Networks, and Hibernia is based in the U.S., and they have built a global high-capacity, low-latency network in areas of Europe, Asia, North America, and including a submarine, transatlantic submarine cable system, very low latency. So, sorry to bore you, but what do we mean by cloud? Everyone says cloud. Cloud is everywhere, content's everywhere. Cloud simply means a remote set of resources that can be accessed. All right? Now let's move on. So in the cloud models, the sort of underlying infrastructure as a service, and this is primarily where we play in a network-based or cloud-based network management model. It's really a system-level management that can provide security, networking, other services, and invisible to the end user. The next layer up from that is platform as a service. This is all for application development. You're probably familiar with Microsoft's Azure or .NET application frameworks. And then lastly, software as a service. Everyone's familiar with this as well. We all use Gmail, Google Apps, or Salesforce.com. Those are fully functional software models served from the cloud. And then there's other models, of course. There's your backend as a service. That's primarily a mobile device resource cloud, and there's others as well. But those are the main three that we're talking about here. So what's made this possible is SNMP, and I'm talking about cloud-based network management. SNMP, universal standardization to be able to configure, control, and monitor devices throughout the network. Moving the polling of all those network devices from a central location to a regional has really opened this up, right? Because the delays and the latencies and just the bandwidth required was too much for a central server to be able to handle. Just the fact that the network devices are very intelligent now really opens this up. And then lastly, the fact that there's availability and a lot of bandwidth to give access to the cloud. So at Dometis, this is our very high-level model of what we're talking about. We're talking about a central server and each regional location having its own instance of Boss Link Manager. So there's an obvious synchronization that needs to go on between the regional and the central areas should there be a disruption in access at any point there. Another point to make here is Dometis makes universal drivers, so that talking to all the devices at the regional level is very easy for us to do, no matter who the manufacturer is. That along with SNMP. Security considerations, very important. Are we talking about a private or a public cloud? And we're talking about access to the cloud. Are those connections encrypted? Do they have security policies enabled with them? What does the encryption look like? Is it an end-to-end encryption? Is the cloud encrypted? Machine-to-machine communications is another big security concern, as these machines are smart and have conversations back and forth. Can they get access to the cloud in an unauthorized manner? Your APIs, your application programming interfaces have keys and passwords, authentication. How is that managed? And then lastly, the SNMP traps. Putting SNMP everywhere on your cloud is a smart way to start monitoring all traffic and looking for anything that might be rogue, right? And then lastly, security policy. This is very complicated because there's a lot of people involved in this architecture. There's carriers, the equipment providers, the customers, the end users, and how do those security policies all synchronize together? We talked a little bit about reliability and failover systems. Scale, just the number of devices on the network today. Cisco has predicted by next year there's going to be 25 billion network devices out there. And in the next 5 years, it'll go up to 50 billion. That creates a lot of traffic, a lot of latency, a lot of polling. So how do we manage all that? The connections to the cloud have to, of course, scale up to match all that. And then customer-specific needs, that's really, from our perspective, all our customers have unique security requirements. They have unique architectures and equipment. So how do we scale our company up to serve them? Do we make a one-off product for every customer, or do we make a standardized product and then try to customize it? And then the big one is service level agreements. First of all, how do we measure what's going on in this cloud, and how do we know, you get the data and get the reports, and then how is that backed up? How is that? How do we offer that to the customer? How do we report it, and those kinds of things? So that's the general background of what we're looking at. I want to turn it over to Wes now, and he's going to talk about Hibernia's experience with the cloud and Dometis.
Thank you very much. So I'll put these on so I can read what I'm presenting here. What we have up here is an actual demo that we've put in place on Friday. This is for a major sports right holder to a couple of major leagues of events and activities. So we are fully embracing of the cloud as it is today, not only from our private environment that exists in that we have a network of over 300 some devices out there over private line environment, but also going out through the public IP, and we have our own CDN that we're also delivering content. So the cloud is effectively everywhere. There's no point that whether you're in a home, whether you're in an office, whether you're in a major football stadium, whether it's the World Cup, whether it's a simple interview of somebody, whether it's coming off of a cell phone, eventually, the devices that we hold in our hands will be more and more active elements on the cloud with the wireless bandwidth. I'm not showing wireless at all at this point here, but we see that as being the next step where the cloud is ruled. Now, of course, there's certain SLAs as you go along here. The pursuit of the future is really what the cloud is all about, because before the whole cloud name or before the whole environment of trying to get everywhere, people thought, oh, okay, I get my microwave lines. There was no concept of a cloud. There was just connecting from point to point. There was connecting inside of a studio. There was some fiber connectivity. There was nothing that related to cloud. Then you started going out with IP addressing schemes and internet and universal routing and browsers. And so today, then all of a sudden we said, oh, well, let's call this the cloud. And so what we have as our private environment is now just an element of the cloud as a total. So in order to manage that, how do I take and have it transparent, where I can have a signal that's on the private environment and be able to connect to something that's on the public world and ubiquitously gather it, get to the information. Then there's what characteristics do I manage on that thing? Glenn brought up a really important element in our minds, is that of how do I manage the security? How do I manage that those devices are not going to be penetrated by somebody that shouldn't be getting onto that device, shutting down a major event? And that's one of the security elements of gathering content and delivering content, or key elements of delivering over the cloud. So those of us that might have been around this business for a little longer, broadcast loops, whether T1 or TV1s, they're no longer that TV1, that analog loop. It's now an Ethernet private line, or in many cases, what we're demonstrating here, we went in and stuck our gathering equipment on the other end of a public IP connection. Now, the bigger that public IP connection can be, the bigger the bigger the stream that we can have come out of that location. So you no longer have just that one element where you can call it up, where it was a TV1 or T1. You could call up somebody and say, hey, I have a problem with this link. I have a problem with this loop. So the Colts, in the US, the AT&Ts, guys like that would go in and check whether the link is bad. Now, if you go and connect via the cloud and you have your public IP, everybody goes, I have no idea how that's going there. So then you have to get intelligent on managing port congestions and such like that. So then you really get into, you're no longer just switching, you're routing your signals. How do I know if I've got, when I go and test out my connection on the cloud, that it has inside of that cloud multiple routes? Do I control all those routes now, or do I just control how those routes are managed and are recovered? So QoS rules, so you go in there, you're diminishing the ability to your control, but now you have demands for higher QoS. When just not that long ago, in 1997, 1998, if we were able to recover from a fiber cut or a network problem in 15 minutes, that was an exceptional time. That was an exceptional recovery time. We now have people complaining if we have a switch hit, when we have the system going from primary to protect, going, oh, I took a hit on my video, I saw that glitch. You know, what's happened with that glitch? Well, that's good that we have people watching that, but that just is not it's not a complaint from our part. It's more of like where the market has gone up to. Most of our providers are now providing network-based switchless hit management for the routes from the primary path to the secondary path. One key provider we have, the Net Insight platform, which is controlled, that does that universally on their platform. So the customer that does not see any hit, even if there's a network outage. So gone are the days of the network recovery. What do I next? I press the next button to go to the next. So here's our network, an element of our network as you see today, the main backbones. The important part here is how do we communicate with all these different devices, not just the devices within our network, but devices that the customer is putting in premise that we're able to control and communicate with. And SNMP has really given us that capability, and now we're going to eventually go into software-defined networking. How does that take us to the next step? And then management of circuits over hybrid. I don't know. Somebody trying to call me here. Sorry, I'll turn this off. It's not an outage. So, management of circuits carrying hybrid services. Once again, in the earlier days, or days have passed, and many of the services we define today is getting a video from one end to the other. Now, when you get a connection, okay, I want to have this dedicated connection for this channel that's up all the time. Well, in that extra bandwidth that's sitting over there, I want to be able to do some OU services. And then in that extra bandwidth that's sitting over there, can you give me a data service connecting from here to here? And then when the OU is not on and my data service is not on, can you have that bandwidth backfill and give me public IP so that I don't have any wasted bandwidth? And if I'm spending money from you, how do you do that? And at the same time, make sure that my public IP does not in any way impair my ability to give high-level QoS for video when I'm contributing an interview or contributing a sports event. We had a little event on Wednesday. There was, I think, the entire event crashed from, I don't know, the announcement of the iPhone 6. Did anybody here try to watch that? Were you actually able to see the video? No, it crashed. Everything crashed. Now, we're talking about a tiny little company called Apple. And they have all the resources, but how do you control that QoS? So it's obvious. Now, let's say if I'm doing a coverage of a sports event at that time, and I'm using the internet, and I'm using one of those CDN infrastructures, and now I'm trying to cover that sports event, and somebody comes along, like an Apple, and they have all the right in the world to use the internet, just like everybody else. They crashed everything. So now I'm trying to get coverage of my event, and so how do I control that QoS? How do I control that environment is another thing that we have to step into. Once again, the argument of managing the circuits from dark fiber to public IP. You've got to be able to take care of that entire cloud environment. And so the SLA changes a little bit when it's getting over here on the CDN, changes a little bit tighter when you get over to public IP, and then gets to its highest level when you have dual dark fiber and whatever redundancy infrastructures. And there is, by the way, no such thing as 5 nines. People will talk to you about that unless you want to spend a whole bunch of money. 4 nines. We have some. Actually, we put 5 nines into marketing, and we had a customer that said, "Well, mathematically, are you going to pay us to get to that level? That means like 20 seconds of outages a month." Well, that's a little tricky. So they made us back off to 4 nines to the mathematics. So that was an interesting thing. So take it out of marketing and put it into reality. It was both a German and a Swedish customer that did that to us. So, anyway, took the North American marketing out of the actual product. And so NMS interfaces. The first element that we have to do, we have to control the devices in the network, whether it's a device that we own or a device that the customer wants us to control and monitor. And then that's the basic part. That's the part that one of the reasons why we've gone to our core companies that we work with is that they do an enormously good job at controlling the device. How do I know what's going on with that device? Then on top of that, you got to be able to bill it. How do you manage the billing? How do you manage the booking? How do you manage all of that environment? And how do you make that seamless so that when the booking system goes and requests an event, it knows that the network is actually available? How do you get that information on that booking system out to the operators real time? How do if I have a maintenance event, and we have a network that has thousands of circuits on it, and I have a maintenance event on one element of the network, I have to be able to log that into the network. And the booking system people need to know that that bandwidth element is not available to them when it comes up to this maintenance event. So you have to put maintenance faults, and you can't just be booking satellite capacity, booking a trunk or fiber trunk, and then it becomes unavailable. This doesn't work. Customers are not really happy when that happens. How do you make that same information available to the customer? So web access, just like say internal as well. Do I need to have every person sitting in a control room? That was the old days. They were sitting in the control room, the computers and the servers and everything, and then you had your LAN, and that was how you got into a booking system. Well, today, our booking system environment is ubiquitous. Somebody can be sitting at home. In fact, our control system for our Swedish network is in Maryland, and the person who's managing all of the relationships with our Swedish customers is based in Stockholm, talking over a VoIP system that's main SIP environment goes to the UK and Dublin, going back to a computer in the United States, and then they're talking to them and managing it all from their home, and the customer knows nothing about that. They just know that they're talking to a person that's in Sweden that can speak Swedish or whatever appropriate customer interaction, knows where the names, the stadiums. So the web access allows us to do all of that. We do that all through secured web access. Now the next part is how do I put that all more and more and more into the hands of the customer? So I have to have my security environment. So then there's the reporting. Customers want to know at the point that they press the enter button, or maybe not even the point they press the enter button, before they press that, how much is this going to cost me for an individual order? At the end of the day, how much have I ordered? The end of the month, what did I order? Do I have any problems on any of these orders? We're going to maybe avoid giving them SLA reports so they know where they get credits on a feed that day. But, they want to know exactly what happened real time, because most of the customers are trying to put something in, whether it's like, this talk show, this news magazine. They do a booking, they got to put it right into that booking for that actual event to know what it cost them to do that event. And so the real-time reporting back to them, and that the customers get the same reports as as we do. And then the ticketing system. We hate the ticketing system because that means something happened that we don't want to. We wish we didn't have a problem. But then the transparent environment between our ticketing systems and such, and those are the key elements that give you the overall goal of transparency of the network, transparency of the cloud, whether it's coming off of your CDN, your IP network, your private line network, devices that we universally or unilaterally control, or the customer controls and we're managing for them. So that's how we see the management of the cloud as it is today, and where it's going forward in the future. So the final thing, managing over the internet, managing file transfers along with linear media, interface types of the control systems. That has, SNMP is there today, but that has another evolution that's going to come into that whole environment. And how do we reach the CDN services? That is, it's all been going to that little device, that iPad, that iPhone, that Android phone, whatever. But as an associate I work with, who's the CTO of Turner Broadcasting, Scott Teisler, he had a mandate in 1998. He said, and truly a visionary in my mind, he said everything is going to be IP and everything is going to be over the internet, and then this CDN thing is going to become the rule at some point. In 1998, and another friend of mine who's retired now, his bonus was based upon driving Turner towards the internet for use of gathering and distribution of content at a very high level. So thank you very much.